you're a person who has a foundational understanding of Scrum and Agile. You have experience in Agile environments as a Scrum Master or an Agile coach or a product owner or manager. And now you're interested in advanced topics. If that describes you, this course is for you. This is Introduction to Agile Systems Thinking with Causal Loop Diagrams. My name is Michael Bellamotha. Feel free to reach out to me on Twitter, LinkedIn, my website, or email. I have a PhD in computer science, and I'm a Scrum Alliance certified enterprise coach. This course has 5 topics. We'll start off with theory, focus first on old school linear systems, which we're all familiar with. Then we'll move on to new school nonlinear systems, and then we'll dive into the tool itself. I'll introduce causal loop diagrams. We'll start building out causal loop diagrams in Loopy, a free online tool. And then I'll show you some causal loop diagram examples that pertain to software development environments. So you'll end up with a much better understanding of linear and nonlinear systems and how they radically change our approach to increasing agility in an organization. And you'll take away some videos and tools that you can use to further improve your understanding and to share with your colleagues at work. Let's dive right into it. Old school thinking is characterized by believing that systems are decomposable, that reductionism works, that we can take a system, like an organizational system, split it up into little parts, understand each of those parts, and then the properties of the system as a whole can be easily derived from those simple little parts and the way they behave. Systems are such that the cause and effect relationships are fully known. It's like we live in a clockwork universe. So if something happens at time t equals 100, we know exactly what is going to happen at time t equals 205,000 and 10 million. Things just run forward like a machine. The systems are predictable. If we understand the initial conditions, we understand how the little pieces work together, then the future dynamics of the system can be calculated. There are no surprises. So systems with these properties are called linear systems. And linear systems lead to this very simple, straightforward problem-solving approach that we're all familiar with. If systems are decomposable and predictable, then the way that you solve problems is you get a bunch of smart people in a room. We often call them executives or managers because they understand the entire system. Then they solve the system and then they roll out the solution. And this always works. Why? Because reductionism works, we understand the cause and effect properties, the systems are predictable. And so this approach favors top-down management because they have the best overview of the entire organization, an assembly line approach because things are decomposable and additive. We can take pieces from one part of the organization, smash them into another part of the organization, and that will be just fine because there are no strange effects that happen above the levels of the components. Everything is easy to understand and predictable. And it also leads to dehumanization. That's, of course, a personal opinion. But if we think of human beings as input-output with no internal state and no unpredictable behavior, if we believe that we can predict individual and group performance, then we don't really need to focus on human beings and key things like psychological safety and trust. Human beings are just a piece of a machine. And so what we've discovered is that thinking of the world as a linear system is probably not ideal if what we want to do is increase organizational agility. Stanislaw Ulam, one of the great mathematicians of the 20th century, said, using a term like nonlinear science is like referring to the bulk of zoology as the study of non-elephant animals. So what we've discovered in the Agile community is that treating an organization as a linear system is an error. So let's talk now about the new school way of thinking and viewing an organization as a nonlinear system. So nonlinear systems have emergent properties, properties that are not deducible from the properties of the component parts. So reductionism does not work. So you cannot say, I understand this little piece of the system, I understand this little piece of the system, and therefore I understand how the system is going to behave when all of the little pieces are combined together. There are properties, emergent properties, that occur only when the systems are together. The cause and effect relationship is not known. A simple example is, why did the stock market go up today? So the stock market is a nonlinear system. And the ability to control the system is limited. Instead, all we can do is experiment and observe the results. So fundamentally, these systems are unpredictable, and therefore that breaks the old school form of management. So examples of nonlinear systems are ant colonies. We could understand every single ant and not understand how an ant colony works. The weather, we could understand every cloud in the sky and not understand how the weather works. The game of life was created by the applied mathematician John Conway. It has these very simple rules. You can play the game at this URL, but despite the fact that it has these simple rules, the behavior of the system is nonlinear. So we cannot predict the system, even though the component parts are very simple. And traffic is also a great example of a nonlinear system. We can have traffic just flowing, and then all of a sudden there'll be a delay. And the delay is caused by these very complex interactions and unpredictable interactions amongst the cars. So my take on this is that one of the fundamental shifts that occurs during an agile transformation is to change the perspective, typically of management, that the system is like a linear system, and understand that it's actually a nonlinear system. And this is typically earth-shattering. So simulations and games help. So one simple game is try and program a better ant. If it were a linear system, it would be very easy to program a better ant. Because it's a nonlinear system, it's much harder. And then focus on increasing agility, the ability to respond to change. If the organization is not predictable, then the most important, most valuable thing that we can do is nurture the ability to sense and respond to change. So if you're really interested in these topics, check out this video by Aaron Dignan. It's a Google Talk. You can check it out on that link.